Okay, I hope I'm audible to all the students who are attending this lecture of Introductory Econometrics. Okay, we in this lecture look at the topic of regression, which is the core topic within Introductory Econometrics, and this lecture is primarily based on the concept of linear regression. So we look at the concept of linear regression. We will be devoting a few lectures on this topic. Okay, so the reading which I will be following for the introductory econometrics course, this is Damodar in Gujarati. This is the reading I will be following. And along with that, I will also be focusing on another reading by Christopher Dougherty. So in our entire econometrics course, I will be introductory econometrics course. I will be focusing on these two books for my lectures. Damodar N. Gujarati, I will be focusing on the 4th edition of this book for my lectures on econometrics, and Christopher Dougherty also we will be looking at for some of the important proofs. Okay, so now guys, first of all, let's understand what is meant by regression analysis. When we study regression analysis, what does this mean? So regression analysis is concerned with the study of relationship between one variable called the dependent or the explained variable, and one or more variables called the independent or the explanatory variables. Okay, so when we look at the regression analysis is basically concerned with studying the relationship between the dependent variable, which we also call as the explained variable, and one or more variables. It can be one variable, it can be more than one variable, which we call as the independent or the explanatory variable. That means, guys, in the regression analysis, we will only have one dependent variable, but we can have many explanatory variables. We can have one or many explanatory variables. But all of you need to understand, regression does not mean causation. So it does not mean that the explanatory variable is causing the changes in the dependent variable. Regression analysis will only capture the relationship between the two. It does not mean causation. For example, suppose all of us in introductory microeconomics know the simple demand theory. Now, guys, all of us know the law of demand. It simply states that keeping all other factors constant, a rise in the price of own commodity causes the quantity demanded of that commodity to fall. Now, in this case, price is causing changes in demand. But when I look at the regression analysis, I am not commenting on what is causing changes in demand. I am commenting on what is the relationship between demand and price. So you need to understand this. Why? Because when I write a regression, suppose I write a regression for you like this. Regression is nothing but an equation. All of us know the demand equation. D is equal to A minus BP. This is my linear demand equation. This is my linear demand equation, right? Now, guys, changes in demand can happen because of other factors also, which you have done in microeconomics like income, taste and preferences, price of substitute goods, complement goods. But when I am writing a regression equation, I am looking at the relationship between demand and price. I am not looking at what is causing changes in demand. So this example was taken just to explain you the point which I am going to write. So all of you can write this point along with me. Okay, so write a note. Regression does not necessarily imply causation. Regression does not necessarily imply causation. Okay, so I hope students have understood this. Now, guys, why do we study regression? So a motivation for all of you, you can write objectives of regression analysis. Objectives of regression analysis. So one objective of studying regression is to estimate the mean or the average value, to estimate the mean or the average value of the dependent variable given the values of the independent variables. Given the values of the independent variables. So guys, given the value of independent variables, we want to estimate the mean or the average value of the dependent variable. Second objective of studying relation, to test the hypothesis. To test the hypothesis about the nature of dependence. To test the hypothesis about the nature of dependence. Okay, so we want to see to what extent is the dependent variable dependent on the independent variable. So we will be doing hypothesis testing in regression also. For example, we would be interested in seeing to what extent is demand for a commodity dependent on the own price. So we would be interested in doing hypothesis testing for the same. Okay. Third reason for doing regression, to predict or forecast the mean value, to predict or forecast the mean value of the dependent variable, to predict or forecast the mean value of the dependent variable given the values of the independent variable, given the values of the independent variable beyond the sample range. Now guys, what does the last point mean? Last point means regression will also allow us to extrapolate. I hope students have heard this term before, extrapolation. Extrapolation means it will allow us to forecast what will be the value of the variable in the future based on the past trend. So I hope students have understood the reasons for studying regression. We would want to estimate the mean or the average value of the dependent variable given values of a few independent variables. We would want to test the hypothesis as to what extent the dependent variable is dependent on the independent variable. We would also want to extrapolate, or we would want to forecast what would be the mean value of the dependent variable in the future, in the coming time periods, given the value of the independent variable. Beyond the sample range means what? Beyond the sample range means we would want to extrapolate or predict what will be the values of the dependent variable in the future beyond the sample range, beyond the sample which we have taken. So I hope all students are convinced as to why regression analysis is the core of econometrics. Okay, now guys, we are formally starting with the theory of linear regression. This was a motivation for all of you. I hope you are motivated now to study further contents of this course, because ultimately we will be doing a lot of economic models where we will be looking at the relationships between the dependent and the independent variables. For example, demand equation, supply equation, Angel's curve, which you have done with me in intermediate microeconomics course. So all such relations, the Phillips curve relation, which all of us have done in macroeconomics, the Okun's law relation, which all of you have done with me in intermediate macroeconomics. So all these relations we will now be studying through regression. Okay. So guys, erasing all this, uh, let's first define now what is meant by population regression function. Population regression function, also called PRF. Okay, so guys, let's write the theory behind it. Let X denote the explanatory variable. Let X denote the explanatory variable which is non-stochastic. Now students should be familiar with these terms. What is meant by non-stochastic? So non-stochastic variable is that variable which has no probability distribution attached to it. Basically, that variable which is taking fixed values is a non-stochastic variable. If you have a variable which has a probability distribution attached to it, it is called a stochastic random variable. If you have a variable which is taking fixed values, it has no probability distribution attached to it. It is taking fixed values, that is called a non-stochastic variable. So let X denote the explanatory variable which is non-stochastic, and Y denote the dependent. Y denote the dependent or the response variable. It denotes the dependent or the response variable which is stochastic. Now guys, what does this mean? This means that Y is a stochastic variable, means it has the probability distribution attached to it. When I say that Y is a stochastic random variable, it means it will take different values with different probabilities. However, when I say that X is a non-stochastic variable, it means it will take fixed values. There is no probability distribution attached to it. So now, for each fixed value, of X, there exists a range of possible values of Y. So for each fixed value of X, there exists a range of possible values of Y. So what can I say? That is, for each fixed value of X, there corresponds a conditional probability distribution of Y. There corresponds a conditional probability distribution of Y. The expected value of this distribution is called, I can write expected value of X, Y, given X takes a particular value equal to small x. Okay, now guys, you can understand this better through a diagram. So look at the diagram which I am drawing on the screen. So this is my x-axis, this is my variable X, this is my variable Y. Now guys, X is a non-stochastic variable. It is taking fixed values x1, x2, x3, xm. Think of X as income, for example. Think of Y as consumption. Now guys, now comes the main line. For every value of X, you have lot of values of Y. For every value of X, Y itself is a random variable. Similarly, for values of X2, different values of Y. For values of X3, different values of Y. For values of xm, different values of Y. That means for every value of X, I can say that Y itself is a random variable. Okay, now what am I interested in? Out of all these values of Y, this particular value will be expected value of Y when X takes the value equal to x1. I can write it like this. This particular value will be, I can say that this is my expected value of Y when X takes the value x2, average value of Y. This will be expected value of Y when X takes the value x3, and so on. I can say this will be, so guys, I can extend the diagram. The diagram is more clear in my lecture notes, access for which will be given to all the students. So you can see for every value of X, I have found out the expected value of Y. Now what do? I join all these points. I join all these points. What is the straight line giving me? This straight line is called the population regression function. This straight line is on your screen. The red straight line on your screen is called the population regression function. So I can write, since it's a linear line, how can I write it? I can write it as expected value of y given capital X is equal to small x is equal to b1 plus b2x. For all b1 and b2 belonging to the set of real numbers. Guys, this is how you write a linear function. This b1 is the intercept term. b2 is called what? It is called the slope. So I have written the equation for this line, and now I am writing the theory further. So guys, I am erasing the initial part now. I hope all students have understood the. So you can think of it like that. For every income level, you have lot of consumption levels. For every, suppose you think of X as income, you think of X as income, you think of Y as consumption. For every level of income, you have lot of people with different levels of consumption. Now, out of all those consumption levels, I am picking up the average consumption. So for the income level X1, what is my average consumption? This is my average consumption. For income level X2, I have lot of consumptions, but what is my average? This. For income level X3, I have lot of consumptions. What is my average? This, and so on. So I'm joining all these averages, which gives me the population regression function. So erasing all this, and the theory is not over yet. Let's further write more on this. Also, students need to understand that the nature of the course is mathematical and numerical. But in order to understand that, you need to understand this theory first. If you don't understand this theory, you will not be able to do numericals for this particular course. That means the theoretical base should be very strong. So now guys, if I move forward, okay, so I can write expected value of y given capital X is equal to small x equal to b1 plus b2x for b1 comma b2 belonging to real numbers is called the population regression function. This is called the population regression function of y on x. It's called the population regression function of y on x. Okay, okay, and also called, so this is also called as, it is also called as the deterministic. It is also called as the deterministic or non-stochastic population regression function. It is also called the deterministic or the non-stochastic population regression function. Guys, why is it called deterministic? It is called deterministic because I know all the values on the right hand side. I know the value of b1, I know the value of b2, I know the value of x. Since I know all the values on the right hand side, hence this function is a deterministic or non-stochastic population regression function. Okay, so I hope students have understood this. You can now write capital B1 and capital B2 are called the regression coefficients. Capital B1 and capital B2 are called the regression coefficients. B1 is called the population intercept coefficient. Population intercept coefficient, and capital B2 is called the population slope coefficient. Capital B2 is called the population slope coefficient. So far, I hope students are all clear with this. So you can clearly see that the population regression function is a straight line having the intercept as B1. So you can think of this as the intercept. This is capital B1, which is my intercept term. And the slope of this is equal to B2. The slope of this line is equal to capital B2. So I hope students are clear with the concept of population regression function. Now, guys, we should know how to interpret B2. How to interpret B2, how to interpret B1. Okay. So, but before doing that, we can also write one line as to what is expected value of y given x equal to xi. So, guys, I'm erasing all this now. So I can write a few points as no. So expected value of y given x equal to xi, which I can write as capital B1 plus capital B2 times xi. Okay, this is the mathematical equation. This is the mathematical equation of the population regression function, where expected value of y given x equal to xi means the expected or the mean value, expected or the mean value of y corresponding to, or I can say conditional upon, I can say conditional upon a given value of x. I can say like this: expected value of y given x equal to xi is the expected or the mean value of y conditional on a given value of x. Now all of us can write interpretation of B2. How do I interpret B2? Guys, the intercept term has no economic meaning. Basically, what does B1 mean? It is the mean or the average value of y when xi is equal to 0. The intercept term has no economic meaning, but what is the interpretation of the slope coefficient B2? How do we interpret the slope coefficient B2? So let's write the interpretation. B2 measures the rate. It measures the rate of change in the conditional. It measures the rate of change in the conditional mean value of y per unit change in x. Per unit change in x. So B2, if I talk about the slope coefficient B2, it measures the rate of change in the conditional mean value of y. Why conditional? Because it is conditional on a given value of x. So conditional mean value of y per unit change in x is captured by capital B2. Okay. And another thing, guys, you can write another note. You can write another note that in our lectures for simplicity, we will be writing expected value of y given xi as expected value of y. This we are doing just for simplicity. Okay, so just for simplicity, we will be writing expected value of y given xi as expected value of y. So guys, the population regression function which we have done till now, this was the non-stochastic population regression function, also called the deterministic population regression function. Why? Because everything on the right hand side was given to us. But in the coming lectures, so I intend to stop here. In the coming lecture, I will be discussing about the stochastic population regression function. So basically what we have covered in this lecture is the basic concept of regression, and I have introduced to all of you the concept of uh, deterministic population regression function. I have explained it through a diagram that for every fixed value of the non-stochastic variable x, you have lot of values of the stochastic variable y. We are interested in looking at the expected value of y given capital X takes a particular value xi. We join all these expected values, we get the population regression function. It is a linear line with the slope coefficient as b2 and the intercept coefficient as b1. Okay, how do we interpret the slope coefficient b2? It measures the rate of change in the conditional mean value of y per unit change in the variable x. Okay, and for simplicity, in my coming econometrics lectures, I will simply be taking expected value of y given xi as expected value of y. So guys, what we have covered today is the concept of uh, non-stochastic population regression function. But in the next lecture, we will look at the concept of stochastic population regression function, where we will also have the random error term, which we will do in the next lecture of econometrics. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mics and ask, or you can call up or mail me your doubts at divineschooloфeconomics@gmail.com. So this is where I stop in this particular lecture.